This converges and it's equal to 0. Number 21, this one, if you look only at the degrees, clearly there's x to the 4th if you cancel, so this will converge. Turns out that this is a very clever inverse tangent if you think about it. If we think of this as x to the 3rd squared, we can do a u sub where we let u be equal to x to the 3rd, and when we take the derivative of that we get x squared, and we can sort this out. That's quite complicated. We can talk about that in class, but that's where that is. 22, here again, this is this degree is above 1, so 3 is above 1, and that ln of x goes very slowly. So this would barely cancel with even 1x, leaving x squared down below. So this is going to converge. You can try this one. That would be a good one to practice with. 23, again, applying this reasoning. Here we've got x, 1 over x is our boundary. This will make it go to 0 just a little bit faster, fast enough that it will converge. All right. Here we've got an e to the x over e to the 2x. You can think of that as canceling. You've got 1 over e to the x. That one also is going to converge. All right. Watching the clock here, I'm at 11 minutes. I'm going to try to go quickly on these guys. 25. Pay close attention. This is the first one that's not going to infinity. That's going to 1, and that's going to 0. Where's the asymptote? Oh, the asymptote is 0. Remember, this is like our boundary thing, but in reverse. If I'm saying like y is equal to y is equal to essentially 1 over x to the 5th, then that will normally converge if it's going to infinity. But if I flip this around, it would be like x is equal to 1 over the 5th root of y, and it's going towards the y-axis. So this one would diverge because it needs to be on the correct side of that boundary if we were to rewrite it. And if we rewrote it, it would be only y to the 1/5, and it needs to be bigger than y in the denominator. All right, so that one diverges. 26, again, we're going to a fixed point here that's not infinity. It's the asymptote is at 3. So if that's at 3 and this is the square root function, I need this to be a degree less than 1, and that is 1/2, and so that's okay. So 1/2 is less than 1. So because this is a type 2 improper integral, that will converge. All right. So 27, this is 1/4. This is going out to the asymptote at -2. And that 1/4 is less than 1, which I want it to be, so this one will converge. This one here is greater than 3 going to that boundary, so I need it to be greater than 3 only if it's going out to infinity, not if it's going to the boundary. I need it to be less than 1, and so this one will diverge. Here we've got a function that is to the -1/5, so that's in the denominator, and it's approaching 1 because 1 is between 0 and 33. It's going to do it from both sides, so that's okay as long as this this fraction is less than 1, which it is. So this one will converge. Okay, this one is like our boundary. It's 1 over y. That 4 isn't going to help us enough. So this one is going to diverge. It's right on that boundary. And then 31 is very similar to the other one up with e to the x, whereas this becomes negligible, but that essentially cancels, so that's not helping us. That's going to diverge. These remaining ones are ones that you just simply need to do them. It's not possible to easily see what's happening. Well, perhaps this one could be sussed out. No, I think all of these you need to simply do them out the long way. All right, so the examples then I have are for number 8. Here is one in which we know that it's going to converge because we've got really x to the 4th underneath an x, so we could cancel an x, get x to the 3rd, so this should converge. If I do a little u sub, I can rewrite this in terms of u. I've substituted in my t into my u sub, and I've rewritten these boundaries. You don't have to do it this way. You can just figure out the integral and go back and redo it. either way will work. Here you can see as t goes to infinity, I've now integrated that. I get this relatively simple integral with the boundary of 2 up to t squared plus 2. I sub in my t squared plus 2. I take away my lower bound, and those negatives cancel. I'm taking 1/2 of it, going back to my u sub part, and I get 1/2 of 1/2 is 1/4. So that's the actual area. You can check that out in your calculator. Then in this case, in 26, you've got this one is a type 2 where we're approaching an asymptote. The original graph of 3 minus x square rooted is this flipped square root function. The inverse of that then can be sketched like this. We're clearly going to be approaching this from below, so I write that as t is approaching 3 from the left. Here's my integral. Again, I can do it as a little mini u sub. I wind up with this as the integration with these bounds. I plug in my t and my 2, and I just let t get closer and closer to 3 from below. 2.99, 2.999. This stays positive, it gets to 0, so this part goes to 0, and then this part just goes to 2. So there's your definite integral, improper though it is. Thank you very much.